All right, everyone, the first reaction on your worksheet is going to be a synthesis reaction. These we can always tell what they are because when you're describing synthesis, you're going to see an element plus an element. And that's how we know that this one is going to be classified as synthesis. So for these problems, you want to always start out by writing out your reactants. So this one gives you hydrogen and oxygen. The one thing we have to know when we are writing elements by themselves is we have to decide if these different elements are going to be diatomic. So that is where we check our Oberfinkel. Both hydrogen and oxygen are part of Oberfinkel, so we're going to give both of those a 2. Now, with synthesis reactions, you have an element plus an element, and you're always going to get a final compound. So to get the formula of that compound, you want to crisscross the charges. Those charges are going to come from the periodic table. So with this, you have hydrogen is in the first column of the periodic table. That's why it gets a +1 charge. Oxygen is a nonmetal, so it gets a -2 charge. Once you crisscross those, you're going to get H2O, you're going to get water. Remember that the subscripts from the reactant side don't carry over. When you have single elements, you just want to check to see if those are diatomic. And when you have a formula, you want to make sure that you use the crisscross method. It does not matter what the subscripts are on the reactant side. The last thing that we always want to do with these types of reactions is we want to balance at the end. That's why it doesn't matter what the subscripts are. So we can see that over here on the product side, we have 2 hydrogens, and on the reactant side, we have 2 hydrogens. Now on the product side, we only have 1 oxygen, and on the reactant side, we have 2. So to go ahead and fix that, we want to make sure that we put a 2 in front of water. Remember that 2 distributes. So now you have 4 hydrogens and 2 oxygens. So we want to put a 2 in front of hydrogen. So now when you guys are looking at all of these different formulas, on this side you have 4 hydrogens, 2 times 2, and then over here you have 4 hydrogens, 2 times 2. On the product side you have 2 oxygens, 2 times 1, and then on the reactant side you already had 2 oxygens.